Okay, 3.1. We're talking about functions, okay? So, you guys know what a relation is. A relation is a set of ordered pairs. If it's a function, for every x, there's only one y. We talked about that in chapter 1. So let's review now. If you have a set of points. Colin, can you see it on the screen?
Yeah.
Okay. Yes?
Yeah.
All right, 4a. I just want to know, is a function, yes or no? And how will you know if it is or isn't? What do you look at?
The x's and y's.
The x, not the y's, we really don't care about the y's.
Well,
You look at the x's.
well, you gotta know if there's two y's.
No, you
What
don't
if
know if
there's
there's
two
two
x's?
x's.
Two X's.
Well,
If there's
It's
two
just
x's,
two different y's.
No,
Okay,
it doesn't.
I have a
matter.
different thing going through my head and
Okay.
I can't explain it.
Okay. Okay, so Courtney, is a function in your mind?
No,
Why not?
because one has two
Yes,
y's.
exactly.
Does that make sense now?
Yes, that makes sense. So this one's not a function. Is b a function, yes or no?
Yes.
1, 3, 5, 7, 9, yep, it's a function. Well, so we looked at, that's old stuff. We looked at that in chapter 1, and now what you're gonna do is look at relations in the form of an equation. Okay, here are two relations, A and B. A is 4x, it says 4x minus 2y cubed plus 5 equals 0. How do we know without graphing it, looking at the equation, if it's a function? Well, what you do is you solve the equation for y. So how do you solve this for y? You have 4x minus 2y cubed plus 5 equals 0. What's the fastest way to get y by itself? Can we add it and bring it to this side? So you have 4x plus 5 equals 2y cubed. Now how do you solve this for y? What do you do? Divide by 2. So you get 2x plus 2.5 equals y cubed. Then what? Cube root of both sides. So the cube root of this side is y. Y is equal to, and then the cube root of that. Now, if y is unique, which this is, y is equal to the cube root of 2x plus 2.5, you're good. This is a function, yes. But look at this next one right here. You've got, for b, you've got y squared minus x plus 1 equals 0. When you get y by itself, you have y squared equals x minus 1. Now, do you remember what to do with this? Square root, and then I remember specifically we did something right here before we wrote the answer. What did we write? Plus or minus. So this one is not unique. See, for this y value, you have two different x values. So in other words, this x is being repeated, so this one's not a function. So can you think of a short way? When do we write that plus or minus? Those are the ones we don't, that are not functions. When do we write plus or minus? When the index is even. So a 2, if y is y squared, y to the 4th, we do plus or minus, and then it won't be a function, okay? But if it's y to the 1st power, or 3rd, or 5th, you don't have to write plus or minus. You don't, okay? So if you want to remember it that way, that's fine. Next set. Do you remember how to evaluate functions? What do you do? F of 3. So if I give you a function, f of x is equal to the square root of x squared plus 1. How will you evaluate f of 3? You're going to plug 3 in here. So you get 3 squared plus 1. What's 3 squared plus 1? Square root of 10. How about negative 5? What would you do? Negative 5 squared plus 1. So that would be 25 and 1. Ahead of myself. 25 plus 1 is 26. Square root of 26. Questions on that one? P, what would you do here? Plug in P where you see X, so it would be P squared plus 1, right? That's no big deal. Okay, now what about P plus 1? P plus 1 squared, and then plus 1. Can we do anything to this? More? Can we square P plus 1? What do you get when you square that? You know, plus 1 and then plus 1. So what's a nicer answer? P squared plus 2P plus 2. That'd be another answer. Simplify. And the last one, what would be X plus H? What would you do for this one? I would do X plus H quantity squared and then plus 1. So how will we simplify this one? X squared plus 2XH plus H squared plus 1. There's nothing exciting about that answer. Okay, yes? No. Someone else asked me that, and good question, excellent question. Can you take the P plus 1 out, and someone asked, you have to take the square root of both of those? No, if it were a product, then you could. Very good question. Did everybody hear what he said? Because a lot of you guys are going to want to do that. You're going to want to take a P plus 1 out and a 1. You could if this were a times. Then you could do that, but you can't because it's a plus sign. Good question. Okay, backside. This will be the hardest problem, I think, on your test for you guys. It's called the difference quotient. So let's see if we can turn this into not so bad. Because it really isn't that bad. It's just, you guys just don't go back and look at it before your test. This is called the difference quotient rule. It says, you're going to take f of x plus h. So what you're going to do is you are going to plug into this function x plus h and evaluate it. Then you're going to evaluate this function for f of x. And then those two, you subtract them and you divide them by h. Okay, so I want you to work all the way over here to the left because you're going to need a lot of room. Don't start here. We're going to start on this side and we're going to work this way. So what I want you to do, if you do this in pieces like I show you, it's not that bad. So I want you to plug into this function x plus h. We're going to do this in pieces. So what I want you to do, wherever you see the x value, you are going to put x plus h. So what you have here is x plus h quantity squared minus x plus h and then plus 2. Does everyone get that? I'm going to evaluate the function for x plus h. Now, can you clean this up? Can you simplify it?
Yeah.
What can you do? Before we move on to f of x, what can we do with this?
Square this plus.
You can square this. You get x squared plus 2xh plus h squared, and then minus x, and then minus h, and plus 2. It's a big mess, but that's what you get. Okay, so what did I do? I plugged x plus h into this problem. Got it? Next. Now we're going to plug in f of x. We're going to plug in x into this function. What do you get when you plug x here and x here? You get the same thing. Right, Sydney? Yeah.
Those have to be in brackets.
I put them in brackets because then what I do on the side here, now what I do, I'm going to take this as x plus h and I'm going to subtract that. So what I have here, I'm going to take this, which is x squared plus 2xh plus h squared minus x minus h plus 2. Then I subtract, this is my little recipe here. Subtract x squared minus x plus 2. You can use parentheses or brackets, and then all over h. That's the easiest way I can think of to show you how to do these ones. Does it make sense now?
Sure.
Sure. Are we done? No, what do you think you're gonna do? You know.
Distribute.
You know. Distribute what? The negative, right here. So, x squared plus 2xh plus h squared minus x minus h plus 2. Then what? Minus x squared plus x minus 2. What did I do? I distributed the negative. Now what else are you going to do? Combine like terms. The x's are going to, x squareds cancel. What else cancels? This x and the 2's. So what's left? I see this, and that. That's it. So we have 2xh plus h squared minus h over h. I heard a lot of h's. Can I pull an h out of the numerator? Can I pull an h out and cancel it? Yes. You have h, 2x plus h minus 1 over h. The h's cancel, and your answer is 2x plus h minus 1, simplified. So you'll have 3 of those to practice. Okay, now, the next topic of discussion is with all of these functions, some are functions, some are not, all of these relations, I should say, determining the domain is a treat. What you have to be able, before you can graph any of these, to see the kinds of numbers that you can plug into the functions or the relation to make it work. So there are some functions or relations that it doesn't matter, you can put whatever you want. For example, here are some ones that it doesn't matter. If you have a linear, does it matter what numbers? Your domain is the numbers you put in. Think of a T-chart. Your domain is what numbers could you put in. Can you put any number you want in there for x? Positive, negative, there's nothing. Nothing that's going to stop you. So if you have a linear, it's all real numbers. Your domain is all real numbers. What if you have quadratics, like this? Can you square any number, positive, negative? This is all real numbers. What about absolute value? Can you take the absolute value of any number? Yeah, all real numbers.
I don't think I can put a negative.
What about,
Not the number.
x cubed? Can you take the cube root of a negative number?
Yeah.
Yeah, you can. Can you take the cube root of a positive number? Yeah, you can.
Yeah.
So this one is all real numbers. Okay? So, if it's a cube root or squared or linear, what's your domain? It's all real numbers for your domain. But what happens when you have a square root? Can we take the square root of any number?
No.
No, it has to be positive. So to figure out the domain, what you do is you take what's underneath it and you set it greater than or equal to 0. You want to make that a positive number and solve it. So you say x is greater than or equal to -2. That's your domain. As long as the number is a -2 or bigger, we can do this problem. So how will you write the domain here now? Your domain is from -2 to infinity. So anytime you have a square root, you take what's underneath it and you make it greater than or equal to 0 and you solve. Don't forget, sometimes you might have to flip the sign if you're dividing by negative. What about a fraction? What don't you want in a fraction?
The bottom two.
You can't have a 0 in the bottom of a fraction. So what number would give you, what would x be if you got a 0 down here? A 1. So you don't want 1. You want any number in the world except 1. That's, you can't have that. You can have any number except 1. So how will you write the domain here? It's gonna be negative infinity to 1 with a parenthesis, union 1 to infinity. What the parenthesis does is it says, go up to 1 but skip it. If it were a bracket, you'd be including 1. So that's how you skip a number in interval notation, is by using a parenthesis. Okay, so you're gonna be able to practice those. Next, these are called piecewise functions. So this is how you read it. It says f of x equals, you're gonna use, there's 2 different functions here. One is 2x plus 3. You only use this function if the x value that you're evaluating is a number less than 4. So if the number is less than 4, so look at a number line, if it's 4 or less, you use the top function. If the number, the x value is greater than 4, but less than or equal to 10, sorry. So if it's between 4 and 10, you're gonna use the bottom function. Does that make sense? It all goes by how this is read. So now, if I ask you, if I give you this problem, what's f of 4? Where does 4 fall? Does it fall in this category or this one? The bottom one. 4 is right here. So what you're going to do is you're going to plug 4 right here. You're going to do 4 squared minus 1. What's 4 squared minus 1?
15.
It's 15. What about, what's f of 10? Where do you put the 10 at? Bottom one again. So you're going to do 10 squared minus 1, so which is 99. What if I said what's f of 0? Where would you put the 0? Top one. So 2 times 0 is 0 and then 3. Now, how do you find the domain? This is your domain right here. This is your domain. Condense it to one interval notation. How would you write this? Your domain goes from, it covers all the x values from negative infinity all the way up to 10, including 10. That's your domain. Huh? For this, it's the same problem. It's all of this combined. Last problem, then I'm done with the notes. Have you ever seen this notation? It's called the greatest integer function. What it is a box with a letter in it. I mean, with a letter. In this case, it's an x. It's not absolute value. It's a boxed in number. That means greatest integer. What you're going to do is round down. Round down. You take your number that's in that box, think of a number line, and you always go to the integer to the left. The closest integer to the left. Think of a number line, and you're going to go to the left. So, here's your function, f of x is equal to the greatest integer x. So what you're going to do now is if I ask you to evaluate this, I want you to plug negative 4.1 in this box. Now think of a number line. Here's your number line. Here's negative 4, here's negative 5. Where is negative 4.1? It's right here. So you're going to go to the left. So what's the number to the left? Negative 5. How about 4.9? Good job, 4. It's 4. What about negative 2.9? It's negative 3. Good. And what about 10.9? What is it? 10. Good. You round down. Go to the left. Now I'm going to show you how to do it on a calculator, because you probably didn't know this. How do you do absolute? Whoops. How do you do absolute value?
Math done.
Math num, right? Sorry, guys. So absolute value is math num,
Oh, yeah.
and then what? Math num, and then what? 1, right? Well, greatest integer is math num. Anyone see it? Greatest integer, 5. 5.
Oh.
You see it? Whoops,
No.
sorry. Now plug, whoops, math num, and then do any of the ones we did, like negative 4.1. Hit enter. Sorry, I put abs.
I
Math
didn't do that. I got myself again.
num 5.
Send your angel.
And then negative 4.1, and you'll get what? What do you think it is? Negative 4.1, it's gonna be negative 5.
I missed it. Oh.
Here, I'll say it again.
Okay.
You type in math, num, and then go to int, which is 5. That's the greatest integer, right there. Hit that, and now which one do you wanna test? Pick one.
Negative 2.9.
Negative 2.9, what do you think it is?
Negative
You think it's negative 3. Let's do it. Look at that, negative 3. Do another one. Math, num, int. Do another one. 10.9999999. What do you think it is? 9999999. Keep going. What do you think it is? You think it's gonna be 11? It's 10.
I just don't understand why. Like
You round down. It's just
And
round
you got-
down.
4.1 and you put equals negative 5.
4.1, a positive or negative?
Negative.
So you round down.
Oh yeah. Wow.
So negative 5.
Yeah. Got it.
Got it? Okay, here's your homework, guys. I did it on a worksheet for you.
Oh, sweet.
Thank
you.